Hello everyone, let's continue with the lecture series on NCERT Class 7 Geography, and here we are going to discuss about the second chapter of Class 7. So we have already discussed this chapter 1 called Environment, wherein we have discussed a lot of dimensions of our environment. So here we are going to discuss our second chapter, which is Inside Our Earth. So have you ever thought what is inside the Earth? Right. So the things that we see are all the things above the earth, that is on the surface of the earth. So we basically live on the surface of the earth, and all the environment that is around us, that is on the surface of the earth, right? Be it the atmosphere or the hydrosphere or the land that we live on, the air that we breathe, the water that we drink, everything is that we can see is that which is present upon the surface of the earth, right? So have you ever thought what is present inside the earth? No, right? So in this particular chapter, let's explore what's inside our earth. So here, if you see, if you cut the earth in this way, so here the inside, the core part that you can see over here, so in this way it will have concentric layers. So as you know, the earth rotates from west to east. So if you look at the earth, the inner side, this is how it looks like. So it has concentric layers if you observe, right? So the earth has this concentric layers. That means one inside the other. So for example, if this is the earth, then it has some layers. So this is the crust layer, the upper or outermost layer. Then the second layer, as we go inside, we can observe mantle, and then we have core. So these are the three layers of the earth. So the uppermost or the outermost layer is the crust, and below the crust, as we go inside, you can see mantle, and as we move further, we can witness core. So these are the layers of the earth, that is crust, mantle and core. That means within the earth we have this type of layers, right? Concentric layers, one up inside the other. So in that way we have three major layers, that is crust, the uppermost or the outermost layer. Then as we move further inside the earth, we can witness mantle, and as we move further inside, you can see the core. So these are the layers of the earth, remember this. So this is the first basic thing that you have to know. So here you can see the interior of the earth. This is the interior part, that is the internal parts of the earth. So the earth's interior is a complex structure. So here, as you can see clearly, the inner part of the earth. So it is basically a complex arrangement of concentric layers. That means one inside the other, like we have already seen. So if you consider this as our earth, so within the earth it has some concentric layers, right? One inside the other. So if this is the earth, if we just look at the outer side, this is how it looks like. So this is the outer appearance. But what about the interior ones? The interior appearance, how it looks like? It has concentric layers. That means one inside the other. Right? Crust, mantle, core. Right? In this way, it has concentric layers, one inside the other. Right. So first we have the crust layer, inside that we have mantle layer, and as we move further to the center of the earth, we can see core. So in this way, it's a complex arrangement of concentric layers, and each layer has different types of properties. It has distinct properties and significance. So you can see the importance of these layers. It has different properties, obviously, because the temperature differs and the rocks that are present in these regions are differs, right? And also whether it is present in a solid form or liquid form. So all these conditions differ as we move from one layer to the other. So this is how each layer has its own unique features and unique properties, right? And also it has its own significance or importance. Right. So this is the basic thing that you have to remember about the interior of the earth. That means the interior of the earth is made up of different layers. Right. So that is the three major layers are crust, mantle and core. Again, we have upper mantle, lower mantle, inner core, outer core, and all these classifications. So for now, remember majorly we have this three layers, right? Crust, mantle and core. These are concentric layers. That means one inside the other. So you can clearly see over here, one layer inside the other. So in this way, we have, it's an arrangement. It's a very complex arrangement of these concentric layers. That is crust, mantle and core. It has its own distinct properties, right? And it has its own significance. Then these layers, they include our crust, as we have discussed. So the outermost layer is a crust layer, then mantle. Then the innermost one, as we move towards the center of the earth, we can witness core. So all of these, they collectively contribute to the earth's dynamic nature and evolution over billions of years. So what is the age of the earth? It has billions of years. So through all these billions of years, the earth has evolved a lot, right? So it has evolved a lot. It is not just the same when it was actually born. So it keeps on evolving, right? Depending upon various factors and different conditions, the earth also keeps on evolving. And these layers that we have inside the earth, that is within the interior of the earth, they also contribute to this particular evolution of the earth, right? And also the changing nature and the dynamic nature of the earth. So let's see what these three layers are and what are its constituents. What are the different factors that lead to this differences in these layers? That means we have already discussed that these three layers that we have, that is crust, mantle and core, they have distinct and unique features and properties, right? This is what we have discussed. So let's see what are these, what these distinct properties are. What leads to this uniqueness of each layer, right? So let's have a look at these conditions. So here you can see the earth. So if you look at the earth, so for example, if we have a half part of the earth, so if you just look at this cross section of the earth, inside this we have this kind of a layer, and again inside this we have this layer, right? So this is the surface. So this is the earth's surface. That means the thing that we can see right now on the outer side. We can see the surface of the earth. We live on this surface of the earth. Then the outermost layer that we have, it is our crust layer, right? And then we have mantle layer. And then we have core. So in this way, within the surface of the earth, we can see these kinds of concentric layers, one layer within the other. So we have crust, mantle and core. This is the surface of the earth, right? So here if you see crust, it is the outermost layer. So crust serves as a direct interface with the planet's surface, right? Because crust is the outermost layer that we have, it has this direct interface with the surface of the planet. So just consider the example of core. So this is the surface of the earth. Here we have the crust layer, and then here we have the mantle layer, and this is the core. And here on the outer part, we have the surface of the earth. So which layer do you think has the most interaction with the surface? Obviously, crust will have the most interaction with the surface. It is directly below the surface. But if you consider the core, it has a lot of other layers. Core, then mantle, and then crust. Only then we have the surface. So here you can see the most interaction that any layer has with the planet's surface is crust. So it has direct interface with the planet's surface, and crust, it is the outermost layer of the earth. And here one more interesting fact that you can remember is the crust that we see, it has both continental crust and oceanic crust. So here, if you see, here we have some continents and here we have oceans. So is the crust same for the continents and the oceans? No, it is not. There is a difference in these two. So in case of continents, it is different. And in terms of oceans or water bodies, seas and oceans, the crust has different types of properties. So it is interesting to know that continental crust beneath the land masses, it is more thicker. Remember this. So under the continents, it is very thick, up to 35 kilometers. And in case of oceans, it is approximately 5 kilometers only. Right. So under the continents, the crust is up to 35 kilometers. And in case of the oceans, it is just 5 kilometers. So hope you know about the plate tectonics. So under plate tectonics, have you ever heard about the plate tectonics? So what are plate tectonics? For example, consider this as the surface of the earth. So the entire surface of the earth, it is broken down into different plates. So in this way, it is divided into different plates. These are known as tectonic plates. Right, and these tectonic plates, these are continuously on the move. They always move to maintain that equilibrium and all. It will be always moving. So these movements are again classified into different types, like either the plates, they move towards each other, which leads to convergent boundary, or the plates, they move away from each other, which is divergent boundary, or they just slide past each other, that is transform boundary. So in this way, we have the tectonic plates. So while studying the tectonic plates, you need this particular concept wherein the thickness of the crust, you have to keep in mind the thickness of the crust. Only then you can understand about this plate tectonics, right? So when two plates come towards each other, one plate, sometimes it goes below the other, right? So the one dense plate goes below the lighter plate, right? It goes below. So when two plates come towards each other, the denser plate, it will go below the lighter plate. So you have to also remember what about the oceanic crust and continental crust over there. So there, this concept will help you. That is why watch all the sessions in a sequence and do revise these concepts whenever you watch a particular video. Revise those concepts, right? Then for the future concepts and to understand the future lessons, these basic concepts will help you a lot. So here, if you see the continental crust, it has different thickness under the continents and under the oceans. So the thickness differs. So here, if you see, in case of the continents, the thickness is 35 kilometers, and in case of the oceans, it is just 5 kilometers. Right. So whenever this comes to your mind, just remember that the crust, when you're writing something about the crust, remember the crust is not the same. The thickness of the crust is not the same for both land masses and oceans. It is thicker in case of our land masses compared to the oceanic masses, right? Ocean bodies or water bodies. So in case of land masses, it is thicker up to 35 kilometers, and in case of oceans, it is just 5 kilometers, right? So do remember these details. So then why do we have this kind of a difference in the thickness and what does it lead to? So do you think there would be some effect due to this difference in the thickness of the plates? So obviously there would be some effect, right? So let's have a look at that. So this difference in thickness, it accounts to some of the dramatic topographical variations we observe on Earth's surface. So on the Earth's surface, there is a lot of diversity in everything. So in case of our topography of the earth also, there is a lot of diversity, right? So this diversity is also because of this particular difference of the thickness of the crust on under the continents and oceans. It also contributes to this topographical variations that we observe on the earth's surface, right? And continental crust composition and oceanic crust composition, you have to also remember this compositions, like what it comprises of, right? So is the composition of crust same everywhere? No, it is not. So here if you see the continental crust, it is known as Sial. So why is it called Sial? Because it is dominated by silica and aluminum. That is why it is called as, in short, Sial. This is one way you can remember this easily. And it makes it less dense than the Sima, that is silica and magnesium. So generally we write magnesium as Mg, but here we write it as Ma. Right, just remember this. So this is the composition found in the oceanic crust. So here if you see, in case of continents, the composition is Sial. And in case of oceans, the composition is Sima. Right. So continental crust, we have the Sial, it makes it less denser. So in terms of density, so here the density is less and here it has more density. So you have to remember all these points, the comparison between this continental crust and oceanic crust. The comparison is also very important for us from examination point of view. Try to memorize this difference also. Right. So it has more density. Right. So just let's revise these points. So the crust that we have, which is the outermost layer of the earth. So this crust, it has different thickness under the continents and under the oceans. So in case of continents, its thickness is up to 35 kilometers and under the oceans, its thickness is up to 5 kilometers. Right. And coming to the composition. The composition of the continental crust is Sial, that is silica and aluminum. And in case of oceanic crust, it is Sima, that is silica and magnesium. So because of this composition, the density varies. So the density of the continental crust is less compared to the density of the oceanic crust. So remember this. In terms of thickness, the continental crust is more thicker than the oceanic crust. But in case of density, the oceanic crust has more density compared to the continental crust. So here do not get confused. In terms of thickness, continental crust is more thick because it is up to 35 kilometers and oceanic crust is up to 5 kilometers. But in terms of density, our oceanic crust has more density and continental crust has less density. So this is one point that you have to remember. Right. So that is why I've told you that when two plates come towards each other, the denser plate, it goes down the lighter plate. So how does it actually happen? How do you think this actually happens? So this is because when two plates come towards each other. So for example, one is oceanic crust and the other is continental crust. Then when these two plates come towards each other, if this is the plate which has more density, then this plate, it goes below the other and the lighter one, it remains above. So this is how the denser plate, when they're coming towards each other, they collide and the denser one, it goes below the lighter one. So this is how it happens. So in case the one oceanic plate and one continental plate, if they come towards each other, this is what happens. The denser plate, that means the oceanic plate, since it has more density, it goes below the continental crust. Right. So this is why I've told you that for the plate tectonics, to understand the plate tectonics clearly, you need to have these basics of the continental crust and oceanic crust, the differences between these. Right. So as I've told you, each layer has distinct properties and unique features. So this is one unique feature of the crust, right, wherein it has different features in case of the continents and the oceans. Right. This is what you have to remember. So hope you're clear with the crust part, right, which is the outermost layer. That is about our crust. Next we have mantle. So what about the mantle layer? This is the second layer. So here if you consider this as our earth, this is our crust part, this is core, and this is our mantle layer. So this is what we are going to discuss right now. So coming to this mantle layer, so it is beneath the crust. So here if you see under the crust or beneath the crust, you can see this mantle layer. right? So it is beneath the crust and it extends to a remarkable depth of nearly 2,900 kilometers below the Earth's surface, right? So you have to remember this depth also. For example, if this is the surface of the Earth, so from here, from the surface of the Earth, if you measure the mantle layer that we have, so this mantle layer, the depth of it, it extends up to 2,900 kilometers from the surface, right? So if you just want to go to the mantle layer, if you want to reach the mantle layer beneath the Earth, you have to travel 2,900 kilometers. Until there, we have the mantle layer. It extends up to a depth of 2,900 kilometers, right? So remember this. So this depth is important. Remember this. It is 2,900 kilometers below the Earth's surface. So this is what is the extent of our mantle layer, right? So mantle is not entirely solid. It behaves like a slow-moving viscous fluid on geological timescales. So what does it mean by a viscous fluid? Right. So generally, you would have seen this jelly type of texture, right? It is not completely solid or not completely liquid. So it is kind of a viscous kind of a fluids, right? You would have seen like a gummy kind of, a sticky kind of texture, right? That it has more viscosity, right? Jelly kind of. So that is viscous fluid. So the mantle layer, it is not completely solid. It has this kind of viscous fluid which is moving slowly. So just consider an example. You are standing at a place, right? And just pour some water over there. So just a bottle cap full of water, just pour it over there. So what does it happen? Depending upon the slope of that place, that water, it slowly flows towards the slope, right? Whichever direction the downward slope is, it slowly flows. And if it has more slope, the water, it just flows very fast, right? But consider an example. If you throw some viscous liquid which has a sticky kind of texture, do you think it will move as fast as the water? No, it doesn't move, right? So just do that experiment by yourself. You can understand that, right? If you throw something which is having a viscous kind of a texture, right? Then if you even throw that below, if you pour it below, it will move very slow. Even if it has a lot of slope, it moves very slow, right? So water, since it is a liquid, it flows very fast. But in case of this kind of a fluid which has a lot of viscosity, so it flows very slow. So even that same applies to the mantle layer also. So here it consists of a slow moving fluid, that is slow moving viscous fluid, right? So here you can see this kind of a fluid. So just remember this, mantle is not entirely solid. This is one point that you have to remember. It behaves like a semi-solid or a viscous fluid which is moving very slow. So this is what is present in the mantle layer. Then the convective currents within the mantle are responsible for the movement of tectonic plates. So as I've told you before, the entire surface of the Earth, it is divided into various tectonic plates. So it is broken down into a lot of tectonic plates, and as I've told you, these tectonic plates, these are always on the move to adjust, to have this isostatic equilibrium. So all these plates, they're always on the move. They keep on moving to maintain that equilibrium. So for these plates to move, what is the force behind the movement of these plates? It is our mantle layer. Within the mantle layer, we have some convective currents. So this particular liquid that we have, or the fluid that we have within the mantle, we have magma within the mantle layer. You would have heard about volcanoes. Have you ever heard? You have definitely heard about this term, volcanoes. So what comes out of a volcano? It is lava. So lava comes out of a volcano. So where do you think the lava comes from? What is the source of this lava? So you would have at least seen in the pictures or in the movies, etc. You would have seen this volcanoes and lava coming out of the volcanoes. So what do you think is the source of this lava? It is this mantle layer. The magma which is present in the mantle layer, it comes out of the volcano in the form of lava, right? So these volcanoes are in this shape with a vent or opening. So this magma from the mantle layer, it moves through the crust and to the surface, and it comes out as lava, right? This is how it happens. So for this magma, it flows in the mantle in the form of convective currents, right? So it keeps on moving within this layer. So in this way, this convective currents operate. They just move within the mantle layer, right? So in this way, we have some convective currents in the mantle layer. So because of the movement of this convective currents, it also leads to the movement of this tectonic plates that we see, right? So as we know, the tectonic plates are always on the move. So for the movement of these tectonic plates, one factor behind this movement is our convective currents, which are present in the mantle layer. That is in the second layer of the earth. In the mantle layer, we have this convective currents. So this leads to the movement of this tectonic plates, right? And also it drives processes like continental drift, earthquakes, and volcanic activity. So how does this happen? So let's just examine three of these, like all these three conditions. How it leads to these three conditions, right? So then you'll understand the importance of mantle layer. So as I've told you before, each and every layer has its own unique features and unique properties, right? This is what we have discussed. So why does it have these kind of properties? So here you can clearly understand what are the different kinds of properties that it has, and why it has that kind of a unique property, and what it actually leads to, what are the effects of that, right? So here if you see, as I've told you, in the mantle layer we have this convective currents which keep on moving within the mantle layer, right? So these are the convective currents. So it leads to the movement of tectonic plates. This is the first thing. So what about the tectonic plates? So as I've told you, on the earth's surface we have this, it has broken down into small plates, so different sizes of plates, right? So all the plates are not uniform. These are of different sizes. The plates, the sizes of the plates differ from one another. So just go through the map wherein you can see the different plates of the world. So just go through that map, learn that map. So for example, we have African plate, North American plate, Eurasian plate, right? So just go through that, and what all countries are present near that plate, on that plate. Just go through that. You will get to understand how the plates are present and where the plate boundaries are present. So what do you mean by plate boundary? So plate boundary, it is simple. So here you can see two plates. They have a common point or a meeting point. So the place where two plates meet each other, that is known as a plate boundary. So generally, what do you mean by the boundary of two countries? That means the place where the two countries meet, that line is called as a boundary. Or for example, take an even more simple example. So your home and your neighbor's home, you have a boundary, right? A boundary line, which is a wall, a boundary wall is present. So what does it mean? It is that boundary or the limit until which your home extends, and the limit until which your neighbor's home extends. So that is what is a boundary line. So similarly here also, the plates have some boundaries. So when two plates meet at a particular point, that meeting point is known as a plate boundary, right? Remember this. So here we are learning about this tectonic plates. So the entire surface of the earth, that is broken into different plates, and these plates are always on the move, right? So how do they move? It moves in three ways. So what are those three ways? One is it moves towards each other, or it may move away from each other, or they may slide past each other. They may come towards each other, or they may move away from each other, or they may slide past each other, which is a transform movement. So these are the three types of movements that we have. So one is our convergent boundary. When they come towards each other, we call it convergent boundary. And they move away from each other, then we call it as divergent boundary. And when they slide past each other, we call it as transform boundary. Right. So in this way, the tectonic plates, they move in three different ways. Right. So for this movement of tectonic plates, what is the driving force behind this movement? It is the convective currents that we have seen in the mantle layer. So the convective currents, they keep on moving in the mantle layer. So this is a driving force behind the movement of these plates. So as we have seen, the convective currents within the mantle are responsible for the movement of tectonic plates. So hope you are clear till now. Right. So like half this convective currents, they lead to the movement of this tectonic plates either towards each other or away from each other or in a kind of a transform movement. So hope you are clear till now. So what happens when the plates move? Right, because all the life forms, all of us, we are present on the surface, we live on the surface of the earth. And when these tectonic plates, they are continuously on the move. So does it have any impact on us? So can we see some effect of these movements of the plate tectonics or the tectonic plates? Yes, obviously we do experience the effects of it. So what kinds of effects can be experienced? One is, it drives processes like continental drift. So have you ever heard about the continental drift theory? Right. So it was given by Alfred Wegener. So what I said is, the entire continents that we see right now on the surface of the earth. So now hope you are aware of the world map. Right, half the different countries are present and what are the continents that we have. So hope you're clear about the continents. How many continents do we have in total? We have 7 continents. So what are those continents? Asia, Africa, Australia, Europe, North America, South America, Antarctica. So these are the 7 continents that we have. So continental drift of the continents, that is movement of the continents. So we know about the 7 continents that we have. And we know the location, like we have North America, below that we have South America, and in the middle we have Atlantic Ocean, and then we have Europe, then below that we have Africa, beside Europe we have Asia, and below we have Australia, and then even below you have Antarctica. So in this way you have a rough idea or a fair idea of the location of this continents. Right. So do you think this is how it was even millions of years ago? No. According to the continental drift theory, all these continents, they were a single piece of land. So all of these continents they're combined, right? They are as a single land mass, right? So earlier, some millions of years ago, all the continents that we see right now, they are a single land mass. And later, that is, we have this Pangea, right, which is the landmass, and around it we have a sea called Panthalassa. So what happened after this? Due to the movement of this tectonic plates, this particular single piece of land, it got divided into 2. Right, Laurasia and Gondwana land. So in this way, so here we have some important terms. So it got this Pangea, it split into Laurasia and Gondwana land. Right. So later, even after even more movements of the tectonic plates, then even enough whatever continents that we are seeing right now, they have formed, right, due to the movement of these continents. So one day we'll discuss in the further chapters about this continental drift theory clearly and what are the evidences for this continental drift theory. So is that enough if just a particular theory is proposed? No, it needs to have some proofs or some evidence. So I may give some theory that this is how the earth has formed. Will that suffice? No, I must also provide some evidence for it, some proof for it. Only then someone would believe, right? So how can someone believe others' words? It needs some proofs or some evidence. So similarly, for this particular concept of the continental theory, right, continental drift theory, it has some evidences. So in the further chapters, we'll be discussing about this continental drift theory, right, plate tectonics theory, seafloor spreading theory. We have a lot of theories, right? So we'll discuss about all those theories. So for now, since we have come across this plate tectonics and the continental drift theory, we have discussed a brief about it. I've just given a brief introduction of this particular theory, right? So just remember this. So this is the first thing, that is continental drift is driven by this movement of tectonic plates. So why do you think that this continents, all these continents have moved and they got arranged in this way? This is because of the movement of tectonic plates. And why did the tectonic plates move? What is the driving force behind it? It is the convection currents and the mantle layer, which is the second layer. Right, so hope you're clear till now. So that is about the continental drift. Then coming to earthquakes. So what is the relation between this tectonic plates and earthquakes? So have you ever heard about an earthquake, or have you ever experienced an earthquake? So some of you would have even experienced the earthquakes, or else you would have at least heard about the earthquakes, right? So what comes to your mind when we say this word earthquake? It is the violent shaking of the earth, right? So the violent shaking of the land is known as an earthquake. So this is the basic definition that you can do, give the basic meaning of an earthquake, right? So these earthquakes, why do you think they occur? Have you ever thought, why do the land shake suddenly? That too only at specific places, right? Do you think on all the surface of the earth at a time an earthquake occurs? No, it doesn't. So earthquake is location specific. At that location with a particular magnitude and intensity, an earthquake may occur. So why do you think these earthquakes occur? What would be the possible reasons for these earthquakes? So the major reason is the movement of these tectonic plates. So as I've told you, these tectonic plates are always on the move, right? So when they are moving, for example, consider a convergent movement. That means the plates are moving towards each other. So just imagine when two huge plates, so just imagine these tectonic plates that I've shown over here, these appear to be small, but just look out on the map. So try to go through the tectonic plates on a map, then you'll understand a huge continent could be present on a single plate. Right, that means you can imagine how large a tectonic plate would be. So just imagine a condition wherein two large tectonic plates, they come towards each other and even more closer and closer. Then what would happen? Even if they got to meet each other, touch each other, even then they're trying to move towards each other. So what will happen? They'll collide with each other. So when they collide with each other, if there is a difference in the density of these two plates, the denser plate, it goes below the lighter plate. So when this kind of things happen, or else what will happen when the two plates come towards each other, if both are continental plates, then this kind of fold mountains will appear, right? So they will form. So what is a major example of fold mountains? It is our Himalayas. It is a major example of young fold mountains. When two plates move towards each other, they collide. What would happen to this land? It raises up. So that's how this kind of fold mountains are formed, and our Himalayas are a major example of young fold mountains. Right. So this is how that plate tectonics lead to the formation of mountains. But when this kind of a collision happens, when two plates come towards each other, a lot of energy would be released, right? And the plates would be under stress, right? When you're forcing something towards each other, even if it is your fingers, just try moving it towards each other and pressing it. Right, even if it touches each other, if you try to press it even more, what would happen? You'll feel some stress over here. The stress builds up and it leads to some pain. Right, if it is your fingers, when you move towards each other, right, if you're just forcing it towards each other, you'll feel the pain over there. Right, why do you think there is a pain over there? Your muscles and bones, they'll feel that stress. right? So because you're pressing it towards each other, your muscles and bones, they'll feel that stress. So similarly, consider two plates, two large, huge land masses, huge plates, they're coming towards each other and colliding with each other. Then it will lead to the build-up of a lot of stress. So at one particular point, this stress gets released suddenly. So when that stress gets released from a particular point, that point is called as a focus point. So from that focus, the energy gets released. And that energy, so here consider this is the earth. Within the earth, somewhere here, a lot of stress got built up. This is the focus. So from here, what happens? The energy travels in all the directions. But the point which is exactly above this focus, this point, it will experience the most intensity of the earthquake because it is directly above the focus, right? So this is how an earthquake happens. So earthquake, basically it is because of the release of this stress from within the earth's surface. So when this stress gets released in the form of seismic waves, so the energy that is released, it travels in the form of seismic waves. So we'll discuss clearly about earthquakes in our further sessions. So for now, remember, this is how an earthquake happens, right? So this is how an earthquake takes place. So due to the movement of the tectonic plates, which is driven by the convection currents of the mantle, the plates move, and because of this plate movement, the stress would get built up, and this stress, it gets released at some point of time. So that stress, it travels to the surface of the earth, and that is why we feel that violent shaking of the earth, right? Sometimes the intensity would be very high. So at that time, the buildings may collapse and lot of loss of lives and property may occur, right? So that's a different thing. We'll again discuss that clearly under the chapter of earthquakes. In that topic, we'll discuss clearly. So now, hope you have understood the impact of this convectional current, right? So convectional currents in the mantle, they move, and due to that movement, the tectonic plates they'll move, and due to the movement of the tectonic plates, it leads to build-up of the stress, and that built-up stress, it gets released suddenly, and that is how earthquakes occur. So done with the earthquakes. Finally, volcanic activity. What is the relation between this convection currents, tectonic plates, and the volcanic activity? Let's have a look at the relation between these three. So coming to the relation between these three, so hope you are clear till now regarding our tectonic plates and how it occurs and all these things, right? So here, if you see, the plates move in three ways. So do remember the ways in which the plates move. That is, we have convergent movement, divergent movement, and transform movement, right? So now, what about the volcanic activity? So here, as we see in the mantle, we have this viscous liquid. So is the mantle solid in form? No, it is not. It has this viscous liquid, and that liquid, it moves through the mantle in the form of convection currents. So here we have something known as magma. So what does this magma do? It will see that it needs some opening wherein it can come out to the surface. It always searches for some opening so that it can come out to the surface. It just wants to escape to the surface. So whenever there is a vent or opening or a fracture on the earth's crust, through that crust opening, it will just vent out, it just come out. So the magma, always imagine a case wherein the magma is just waiting for an opportunity, wherein if it gets some opportunity, it just wants to escape from the mantle and come out to the surface, right? So just imagine a case wherein the magma, it is just locked up in the mantle, and it just wants freedom, it just wants to come out to the surface. So to get that freedom, it is just waiting for an opportunity wherein if there is a one single vent or opening on the earth's crust, it just wants to escape from there and get out from the mantle. This is what it is waiting for. And whenever there is a vent or opening in the earth's crust, then through that particular opening, it will just come out to the surface. So this is what leads to the formation of a volcano. So this is how a volcano looks like. So here on the surface, this is how we can see this. But below the surface, as you know, there is a layer called crust and then a layer called mantle. And this mantle layer, you can witness magma. So this magma, whenever there is a vent or opening, or even if there is a small fracture on the earth's surface, so through this fracture it will come out. Right. So what is basically a fracture? That is small opening, small crack or opening. We call it as a fracture on the earth's surface. Right. It's a kind of a crack. Right. So from these cracks or from these openings called volcanoes, the magma from here, it travels through the crust, comes to this volcano, and it travels over here and it oozes out. This is how it escapes to the surface. So once it is here in the mantle layer, we call it as magma. And once it comes out to the surface of the earth, and once it comes out of the volcano, we call it as lava. As simple as that. Just remember this difference. Right. So once it comes out of the volcano, we call it as lava. Right. So this is how volcanic activity happens due to the movement of tectonic plates. So when these tectonic plates move, and due to the convection currents that are present in the mantle layer, this magma, it tries to come out through the openings, vents, or the fractures on the earth's surface. Right. So this is how magma, it escapes to the surface in the form of lava. So along with lava, some of the loose stones, right, and other things that come out, ash and all, they'll be expelled out of this volcano. So volcano is also a separate topic wherein we'll be discussing in detail about the topic of volcano in the further chapters. So for now, remember the impact of this convectional currents within the mantle. So the convective currents within the mantle, they lead to the movement of the tectonic plates, and in turn they'll drive the processes like continental drift, earthquakes, and volcanic activity. So hope you're clear with this particular sentence. What are convective currents and how it leads to the movement of tectonic plates, and in turn this leads to the formation of earthquakes, volcanic activity, and continental drift. Right. So hope you're clear with all these concepts. So this is about our mantle layer.